Have you ever thought about a spaceship needing to, pull over and get gas on another planet? It sounds like something straight out of science fiction, right? Well, today, we're going to dive into a real concept from NASA that does exactly that. A mission to refuel on an alien moon and bring a little piece of it all the way back to Earth. Let's get into it.
I mean, really let that sink in for a second. This idea goes way beyond just planting a flag and taking some pictures. We're talking about becoming true interstellar pioneers, using the very atmosphere and liquids of another world to create the fuel we need to come home. It would completely change the game, and believe it or not, it's on NASA's drawing board as we speak.
All right, so let's break down this whole idea of a self-refueling spaceship. This isn't just some fantasy. It's a concept that came out of a really cool NASA program that basically encourages engineers to think way, way outside the box, to dream up the kind of technology that'll power the next generation of space exploration.
So here's the mission in a nutshell. It's designed to solve one of the biggest problems in deep space travel. Think about it. Right now, any mission we send out has to carry all its fuel for the entire round trip. Every single drop has to be launched from Earth, which is super inefficient and costs a fortune. This concept just flips our whole idea on its head by turning the destination into a literal gas station.
Okay, so why Titan? Out of all the fascinating places in our solar system, why go all the way to this one moon orbiting Saturn? Well, it's because Titan is this world of incredible mystery and potential. It's a place that is hauntingly familiar, but at the same time completely and totally alien.
Yeah, you heard that correctly. This is a moon with a thick atmosphere you could fly through. A moon with huge, stable lakes and seas on its surface. It's this incredible natural laboratory for studying how worlds form and maybe, just maybe, for finding out if the building blocks for life could exist in such a bizarre and extreme place.
Just look at this comparison. On one side you have Earth, our home, blue, watery, familiar, and on the other you have Titan. Now both have atmospheres that are mostly nitrogen, but that's kind of where the similarities stop. Titan's sky is a thick orange haze, and its rivers and seas, they're filled with liquid methane and ethane, not water. It's almost like looking at a warped reflection of our own planet.
So, the goal is to grab a piece of this alien world and bring it home. But doing that puts us square up against a massive challenge, one that has been a headache for space exploration since the very beginning: the journey back.
This is what engineers call the tyranny of the rocket equation. Basically, the more stuff you want to bring back, the more fuel you need for the trip home. But that fuel is heavy, which means you need even more fuel just to lift the return fuel off of Earth in the first place. It's this vicious cycle that has made it almost impossible to bring back samples from the outer solar system until now.
And here is where the genius solution comes in. It's like the difference between packing a car full of food for a month-long camping trip versus learning to forage and find food when you get there. Well, in space, living off the land means making your own rocket fuel.
It's a pretty brilliant process. First, the lander harvests the local ingredients, scooping up liquid methane from a lake and grabbing some water ice from the surface. Then, its onboard chemical plant gets to work, creating liquid methane and, crucially, liquid oxygen from that ice. You mix those two together and bam, you've produced a powerful rocket propellant. All that's left is to fuel up the separate ascent vehicle, which then launches off Titan with its precious samples headed for home.
This whole revolutionary idea actually has a name. It's called In-Situ Resource Utilization, or ISRU for short. And you're going to want to remember that term, because it is the absolute key that's going to unlock the future of human space exploration. It's how we'll build sustainable bases on the Moon, on Mars, and eventually venture even deeper into the cosmos.
Okay, the engineering is amazing, no doubt about it. But what's the point of all this? What secrets are hiding on Titan that are worth this incredible effort? Let's talk about the scientific prize.
Getting a pristine sample of Titan back into our labs here on Earth would be a revelation. We could finally analyze the complex organic gunk that covers its surface, understand its bizarre methane-based weather system, and hunt for clues about prebiotic chemistry. The chemical steps that might have kick-started life right here on our own planet billions of years ago. It's a chance to look back in time at a world that might be a frozen version of an infant Earth.
Now, it's really important to understand that this mission is still just a concept. It hasn't been built yet. It's part of this special NASA program that's designed specifically to nurture these kinds of bold, visionary ideas.
The program is called NASA Innovative Advanced Concepts, or NIAC. The best way to think of it is as NASA's what-if department. It's the place where scientists and engineers get to explore those really out-there concepts that, if they work, could totally revolutionize space travel for decades to come.
So here's how it works. This Titan mission concept got selected for what's called Phase 1 back in 2021. That means the team got a small grant and about 9 months to prove that the basic idea is scientifically sound and actually possible. If they pass that test, they can apply for the next phase, get more funding, and really start to flesh out the details. Every single great NASA mission started out as just a single, bold idea like this one.
And this quote from NASA's Jen Gustetic just says it all, doesn't it? The NIAC program is where science fiction and science fact start to get a little blurry. Look, not every idea is going to make it to the launch pad, but the ones that do, they have the potential to completely redefine our place in the universe.
So, as we wrap this up, let's just step back for a moment. This idea is so much bigger than just one mission to Titan. The ability to create fuel on other worlds is a total paradigm shift. It means the solar system stops being a series of dead-end, one-way trips and starts becoming a network of destinations we can actually travel between. The question is no longer, how do we get there and back? It's, okay, where are we going next?